Hi everyone. Okay, I will start our next lesson. Our lesson goal here is a continuation of our last lesson, but what we need to know, and this is our final equation of the unit, is that annuities can work in reverse. And what you learned last time is that annuities are regular payments into an account. This lesson is about annuities or payments that come out of account. So for example, if you have an investment, somehow you get, $1 million. You can receive a certain amount monthly, $5,000 monthly. Let's say you want to try to hang on to that money, so you put it in an account, but you get regular payments monthly. Sometimes this is how lotteries work. Okay, sometimes you win the lottery, and instead of getting a lump sum, you end up getting like monthly payments of whatever amount. Okay, so sometimes lottos get paid out monthly. So what is a present value of annuity? What does that mean? It's kind of like, you can think about it as future value, but backwards, okay? So instead of making payments, you're actually receiving regular payments. Okay, so the word I'm gonna use here is you're getting a payout, not a pay-in, okay? So you're receiving regular payments from an investment. Okay, so I'm gonna put an equation in here, okay, and I have already added it. So I need everybody to write this down, but I have already added it to the front cover of our lesson package. So if we go to this page, I've already added the equations for annuities here, just as a quick reference. Okay, so let's have a look at this equation. So really all of the variables are the same. So R represents a regular payments, but instead of pay in, this is a payout. R is the payout. Okay, and P is the amount of the investment. So here's the interesting thing about this. So let's say you win the lottery and your lottery is $1 million. Your winnings are $1 million. Well, Lotto 649 or whoever doesn't actually have to have exactly $1 million to give you if they're paying it out monthly. What they can do is actually have a smaller amount, but because they're paying it out to you over several years, the balance will make interest, and it'll actually grow enough so that you have exactly $1 million by the time they're done paying you out. So let's read this question. Mr. Bunker has set up an annuity to help his son pay living expenses over the next 5 years. The annuity will pay $50 a month. So let's just, in this space right here, so if we're doing this without interest, okay, without interest, if I have 5 years at $50 a month, okay, my total amount would be 5 years times 12 months times $50. What is that? $3,000, okay? So instead of banking $3,000 now, what Mr. Bunker can do is he can put a smaller amount into an investment, and as it grows, we'll pay it out monthly, but he'll still manage to pay out exactly $3,000. So let's do this. Okay, so let's read the question fully. Mr. Bunker set up an annuity to help his son pay living expenses over the next 5 years. The annuity will pay $50 a month. The first payment will be made 1 month from now, meaning now is time 0. The annuity earns 7.75%, and this is sneaky. Okay, that means per annum, compounded monthly. So the first thing we need to know is that we have to adjust our interest rate, okay, because we've got 7.75% per year, okay, but we need to put this into months, okay, so months. So what we do is we take our rate and we will divide it by 12. Okay, so what we end up getting, I'll write this down. Divided by 12 equals 0.006458. You will need a calculator for this computation, so keep that in mind. Okay, so remember, we've got P equals R, bracket 1 minus 1 plus R to the power of negative n. So we also need to know how to put negative exponents into our calculators over R. Okay, so R is easy. We have it right here. And I just want to remind you that P is what we need to invest now. Okay? This is what we need to invest now in order to pay out $3,000 over a period of 5 years. Okay, so that's the question. We know the regular payout needs to be $50. And then I'm just substituting in 1 minus 1 plus 0.006458 to the negative. Now, n is the number of periods. N will be 5 years times 12, which is 60. We already had it a bit lower. Okay, over R. Now, this is a pretty ugly looking thing, but you have to remember when you put this in your calculator that this negative 60 only impacts what's in that underlined bracket. Okay, the 1 and the minus, those are floating outside. So in my next step, what I can do is continue to write 1 minus, but what I'm going to do is evaluate this this exponent. So I put in my calculator 1.006458 and I raise it to the power of negative 60. Okay, and I'm going to get a pretty gross number, but I have to write down kind of as many decimals as I see on my screen. And the reason for that is because it makes a big difference. All of these late decimals make a difference. Okay, so I'm going to write P equals 50 times 1 subtract that thing, which is 0.3203. This big long guy. Okay, and then when I actually put this in my calculator, okay, so we can see that Mr. Bunker doesn't actually need to put in $3,000 now. He can put in, so now Mr. Bunker should invest just $2,480.56. Okay, so the idea is that it will grow as the $50 are taken out over 5 years for a total of $3,000. So the next question is, how much interest will the annuity earn over this term? And so basically you have to take the total plus total with interest. Okay, and subtract it from the desire, or the other way around, I guess, right? Well, the total with, sorry, this is right. Subtract P. Okay, so the total with interest is $3,000. Okay, that's what we come up with. But we're subtracting out 2480.56. Okay, so he earned, I believe it's 519.44. Okay, so the investment earned 519.44 over the 5 years. All right, let's do the next one. Ethan bought a bicycle for $1,500. He arranged to make a payment to the store at the end of every month for 1 year. The store is charging 9% interest, 9% per year interest, compounded monthly. Okay, so how much is each monthly payment? Okay, so let's look at what we need here. So we see 1,500. We see, so that's the total amount for the bike. Okay, and he's paying for it at the end of the month for every month for 1 year. So let's do an adjustment. We can see right away we need an adjustment for R. Okay, so 9% per year. Okay, so that's 0.09, and because we want to compound it monthly, we're going to divide that by 12. This ends up being 0.0075% per month. Okay. So now, like, the trickiest part of this question is deciding what that 1,500 represents, okay? It is not the regular payments. That is the total investment, okay? So when I look at P equals R, 1 minus 1 plus R to the negative n, R, what we're actually doing is we're finding R. Okay, we're finding the regular payment that needs to be made. Okay, so he wants the bike now. It's basically financing. Okay, so in the end, we know that 1,500 is the cost of the bike now overall. And what we're going to do is try to figure out how many R payments we need to make, or the value of the R payments, if we know that our interest is 0.0075 per month. And if it's at the end of the month for every month for 1 year, we know he's going to pay it off in 12 months because there are 12 months in a year. Okay, and then we need to divide that by 0.0075. Okay, so what we can do now to isolate is we can cross multiply and get the 0.0075 here. R1 subtract. And then this ends up being, I'll do the computation. So we've got 1.00075 raised to the power of negative 12. I put that in my calculator. Okay, so what this means is that Ethan has to pay $131.78 each month for a year to get the bike. Okay, so how much interest is he paying overall? Because obviously, even though the principal amount is $1,500, there's an interest rate there, so we're actually paying more. So how much interest is he paying? So if we look at his overall payments over 12 months, just multiply his payments by 12, we get 1574.13. So Ethan will be paying $74.13 in interest. All right. Okay, so I will leave that with you, and there are some textbook questions I would like you to get going on, and I will see you next class. Thanks, guys.